All right, today we're looking at some simple stoichiometry problems. Beginning stoichiometry. And again, stoichiometry is the study or the calculation of quantities that exist in a chemical reaction. If two things are reacting to form something else, how much of this is needed to produce how much of that? That kind of thing. So that's stoichiometry. We're going to begin with simple mole-to-mole problems. We saw in our previous central question mole ratios, and we're going to use mole ratios to convert from one substance to another. And of course, we're going to use dimensional analysis to solve these problems. So let's begin by looking at number one here. How many moles of hydrogen are needed to completely react with 2 moles of nitrogen? So first thing I'm going to do is go to my dimensional analysis setup. And I'm going to use dimensional analysis to solve stoichiometry problems. And just like any other dimensional analysis problem, I'm going to go through the same steps that I've gone through before. Draw my dimensional analysis setup. Next question, what is this question asking me for? It's asking me for how many moles of hydrogen. So that's my ending unit, moles of H2. And then I'm going to find my given. Are needed to completely react with 2 moles of nitrogen. So that's my given. So I'm going to go ahead and put that on my starting line, 2 moles of N2. Since we're just getting started, I've given you the balanced chemical equation. Later on, we'll have to derive that equation and balance it. But to make it easy, we're going to start off with a balanced chemical equation. Now, one thing that I want to get used to is I want to get used to looking for keywords. Very similar to what we did when we were working with the mole concept. Things like grams, mass, liters, volume, particles, atoms, molecules, formula units. Those are the type of keywords they're going to tell me, do I need another conversion factor in this matter? Moles, not a keyword. So I've got moles here, I've got moles here. I don't need any extra conversion factors. But for every stoichiometry problem, I'm going to need a mole ratio to see the relationship between these different components. So that mole ratio is going to come from the substance in my starting point, and the substance in my final unit. So I want a mole ratio between nitrogen and hydrogen. And I'm going to write that off to the side here. So back to my balanced chemical equation, just like we did in our previous objective, we have 1 mole of N2 to 3 moles of H2. There's my mole ratio. And if I take a look at my dimensional analysis setup, I can see that that's going to fit in perfectly. So I have moles of N2 right here at my starting point. I'm going to flip this conversion factor over so that moles of N2 can cancel out. So 1 mole of N2 to 3 moles of H2. And now I can solve because my moles cancel out. Sorry, moles of N2 cancel out. And I'm left in the unit that I want to end in, moles of H2, and I'm in moles of H2. So now I can just do my math. 2 times 3 is 6, divided by 1 gives me 6 moles. So that's a simple mole-to-mole problem. Again, looking for your mole ratio from your balanced chemical equation.